sharp, and we are going to start. Hello and welcome to Global Azure Austria 2024. I would like to say thank you to all of us coming. We at the Coding Club Linz, we are a community of people who are passionate about technology, and we are also passionate about community. Community is very near to our hearts. We want to bring people together who want to learn about technology, who want to start getting their foot into technology. We want to make it as open as possible, and therefore all we do is for free. And we are super happy to invite and to welcome not just professionals, but also a lot of students, and in the basements also kids where they can do electronic tinkering. They will have beginner coding workshops, and we are super happy to have you all here today. I want to say a big thank you, because all our speakers today took the time on Saturday to come here, travel quite a far way to speak here and share their knowledge to us. A big shout out to the speakers. Thank you for taking the time. Thanks to all the organizers from the Coding Club Linz who made this possible. There is a lot of stuff going on before such an event and during such an event. Also a big thank you to the streaming crew who makes sure that a lot of people can join us over the internet, and that you can rewatch all the sessions after this conference. The spirit of community is super important to us, and such an event wouldn't be possible. Oops, that's the wrong one. Can I have my slide deck? Thank you very much. Thank you. Here it is. Such an event wouldn't be possible without the support of our sponsors. We want to say a big thank you to our long-time main sponsor, Microsoft. We want to make a big shout out to our gold sponsors, Qubito, Dynatrace, Red Hat, and Sulke. We want to say thank you to our silver sponsor, GUID, who are responsible for organizing the bus from Graz. And we want to say thank you to my whole team at Time Cockpit for doing the main organizational work. I want to also thank the HTL Leonding. We are here guests at this school. Typically, this school hosts over 1,000 students every single day. So we have enough room to organize a lot of very interesting sessions. Please be aware that this is an active school. So when you are in the breakout rooms, you will probably see some student material laying around. Please leave it where it is. I mean, if you see some homework laying around, you can do it for the students if you like. But no, just kidding. It's perfectly fine. This is an active school, so please keep everything where it is. Few housekeeping rules, and then we are done, and I will hand over to our keynote speaker, to our first keynote speaker. First, room. We have here in the aula, we have in total 3 breakout rooms, 146 and 147, which is there, E59-1, which is in the basement, the whole food area where you can grab a drink, coffee, and things like that, also in the basement. The restrooms, if you go to the left or to the right, and you turn right, you will find the restroom at the first door on the left-hand side. If you can't find it, please let us know. Do you need a quiet room, or do you need a room for a quick phone conference or something like this? You can always use the open classes. We have a lot of classes here in the house. Just go in and you will have a quiet space if you want. If you are hungry, as I said, the catering area is in the basement. You, of course, can take some coffee or a drink or snack with you, but please bring back the cups and plates and so on after you used it. Wonderful. Food, I already told you that. And last but not least, code of conduct. To make it short, be friendly to each other. This is a community event. We are a community. All the people who are here are volunteers. We try to make this conference as professional and as smooth as possible, but things sometimes happen. Stay friendly, and then we are all good. If you want to read the detailed code of conduct, please visit our website, globalazure.at. Something already happened. We made a mistake. globalazure.at, the mobile view, does unfortunately not show the room numbers. We messed that up. I'm super sorry. Switch to desktop view or take a look at the printed agendas which are on the different walls all around this building. And if you have any questions, feel free to come to me or one of the organizer teams to answer your questions. With that, I would like to welcome our first keynote speaker. We have a living legend under us, Ed Burns, and we are super happy to have you here, Ed. We hope that you have a great time here at Global Azure, and with that, the stage is yours.
Thank you, Rainer. You're very kind. Can everyone hear me okay? All right, let me move the HDMI so I can get my slides on the screen here. Hopefully this works. All right, let's go PowerPoint. Okay, here we go. All right. So thank you everyone for coming out so early on a wet, cold Saturday morning. It's amazing to see so many people being excited about Azure so early in the morning. I don't think I've ever given a keynote at this hour before. So first, a little bit about myself. I've been very blessed to be doing IT for about 30 years now. I started as a student, so it's so exciting to be in a student environment here because that's really where it all begins for most of our careers. Although some people come in later in life, but you know, coming from the beginning, if you're starting out here, the HTL Leonding is a great place to start. So when I was a student, I had the good fortune of working at University of Illinois, and I got introduced to the web at the very, very beginning of the web, and I had a chance to participate as a student programmer, and there's probably a lot of student programmers here, on NCSA Mosaic, which was the world's first graphical web browser, and that was the spark that got me into the web. Many people got into the web that way. And so I started working on the client side. Eventually I found my way to Sun in 1997 and worked on applets. If you used to use UI in Java browser, you would work on applets. They would run using an interface system called OJI, Open Java VM Interface. It was a way to do native code in Java. So to call back and forth, and that's how the applet thing got bootstrapped. Then I found my way over to the server side in about 2002 and worked on J2EE and Java EE, and that was a really great, long and fruitful part of my career where I really found my community. And we created a community around Java EE, we created a community around JSF, and that community is still working today as part of what I'm doing now. I'll get down to that at Jakarta EE. But then I found my way into the cloud in about 2019, joining Microsoft. I became a Java champion then because Oracle employees were not eligible to be Java champions. So when I left Oracle and joined Microsoft, I was able to be a Java champion finally. Now, what I do at Azure, I'll talk about later in the talk, but coming back to community, Microsoft is a member of the Jakarta EE project at Eclipse, and we're also a member of MicroProfile. These are two community-driven efforts to drive enterprise Java forward, and Microsoft is very committed to having these platforms run really well on Azure, which I will talk to you about. I've also written a few books from JSF and a couple books about programmers, rockstar programmer interviews, and this one that I'm giving a talk about, I gave a speech in Vienna on Wednesday night at Dominic Dorn's Java Vienna meetup about developer career master plan. So if anyone's curious about growing their career as a developer, there's a great book that I wrote the foreword for by my colleagues Heather Vencura and Bruno Souza. So I have one copy left for sale if someone's curious about that. So let's get in. Okay, let's start out here with my plan for your time investment. Again, I'm very happy you chose to spend your Saturday morning with me. I'm going to start out with a little overview of the session picks. You have a great agenda. Rainer put together a great agenda today. And I will look through it to see which of the talks were aligned with my messaging. And it turns out there's a whole track of talks that are going to go into a deeper dive of the things that I'm talking about. So I want to highlight that. Then I'm going to make some fairly obvious observations about using artificial intelligence in line of business apps. Then I'm going to show a little bit about two APIs at a Keynote level that you can use AI in your line of business apps. And then I'll close out with Microsoft's approach to using artificial intelligence in line of business apps. So I keep saying LOB apps because that's where my focus has been for the career that I've chosen. Apps that just are kind of boring, kind of dry, but run the entire business. And that's what enterprise apps are. There's many more fun apps out there. And Azure can host them all. You know, we have an amazing product offering for Internet of Things. We have an amazing product offering for Azure Space, right? There's satellites that we have that Microsoft talks to, and you can program your satellites this way. But my focus has been on line of business apps, and that's what Java EE is good for, and many other middleware type platforms. Okay, so the session picks. Let me jump in here. So all of the sessions are great, but these ones happen to align with the talk I'm giving right now. So following my keynote, I'd like to recommend Introducing Microsoft Copilot by Azure, or for Azure by Hannes Lagergrüner. And following that, Unleashing Copilot and Azure by Martina Grom. And then Microsoft 365 Copilot and Microsoft Graph by Tony Pohl. And then during the coffee break, I would like to give, Entschuldigung, während dem Kaffeepause möchte ich ein Sonderangebot geben. Ich möchte White Glove Angebot mit Java und Jakarta EE in Ihrer Azure Anwendung. So können wir einfach plaudern und so weiter, und wir können in Ihre Subscription einfach Java und Azure installieren, wenn Sie möchten. Das freut mich sehr. Okay. Then the last talk, after the coffee break, I'd recommend Infrastructure as Code and AI. Most of the stuff I'm doing at Microsoft is using Infrastructure as Code, using Bicep, which is an Infrastructure as Code language, a DSL custom made for doing Azure infrastructure. All right, let's begin. So, I'm an American fan of this television show, Seinfeld. It's quite old, but the whole point of the show is this guy makes lots of obvious observations and somehow makes it funny. So I really would like to bring to your attention, if you're wondering, what is the impact of AI? How do I get AI working in my apps? Just take a breath and recognize there are lots of market forces at play that have always been in play. I've seen this over 30 years. The vendors that are creating these solutions want adoption. So they will make it super easy to adopt their solutions in your products and your technologies. So if you're worried about how do I learn this, how do I get started, Microsoft will succeed or fail based on how well we make it and how easy we make it for you to learn these things. And so we're putting a lot of effort into making it easy to learn and jump that learning curve. It's not going to be a huge leap from what you're already doing. Now, this gentleman here is James Gosling, one of the people I talked to when I did my book, Secrets of the Rockstar Programmers, and I talked to many other people there. I talked to Rod Johnson, Andy Hunt, Nikhil Katari, Chris Wilson, who was one of the first people who wrote Internet Explorer, who happened to be one of my college buddies at U of I. And many of them, I asked the question, well, how would you get your new idea adopted? And I asked James Gosling this question, of course, and the answer was, how do you package your new idea so that it gets easily adopted? Well, you want to deliver it on the back of existing ideas. So in the case of James Gosling, he said, if I wanted bankers to use automatic garbage collection, I needed to give them a language syntax that was familiar with curly braces instead of lots of iterating silly parentheses like you have in Lisp. So that's the idea, and that's the trend that happens all the time. So let's jump in now into the dev time idioms you'll see with AI. Now, when I talk about dev time, this is just also known as the inner loop, where you're a developer sitting at your coding workstation and you're writing code or grabbing various bits of code from other places and integrating them and doing rapid iterations, deploying, seeing that it works, and it's the tightest form of looping. And there's a lot of technologies that we all know to help make things faster, because that's really where the developer joy comes from. The group that I work at in Microsoft is called DevDiv, Developer Division. This is the group that does Visual Studio Code, the compilers, and they have a huge, long tradition of focusing on developer joy, and the inner loop is where we really can bring that to you. So the way we deliver AI for that is Copilot in Visual Studio and in VS Code. The team I work with also produces the IntelliJ IDEA extensions for Azure, including the IntelliJ IDEA extension for Copilot, and also producing Copilot Chat in Visual Studio Code. Now, I mentioned making it easy to learn. Well, if you're programming in Java or .NET or C# or any of these other languages that we support, we're going to give you language-level idioms that you're already familiar with and deliver the AI in that way. So from the Java perspective, the little bits of AI that I've surveyed, the APIs are always using builder patterns and streams, using the completable future idiom for doing asynchronous programming. Hopefully, with Java 21 being out now since September of last year, we'll be having that also work with virtual threads. Virtual threads is a really exciting Java feature in Java 21 that really allows super great high-performance scaling. Another feature that you can see in some of these Java language AI bindings is functions, being able to pass lambdas around, and also providing an API on top of existing LLMs. So that's the next two things I'll talk about in the next section. Now, coming up a bit from the language level, what about the whole application level? Applications are, lob apps in the cloud are still line of business apps. They're still running your Java code or your .NET code, whatever you're writing it in. And Microsoft is really committed to AIing all the things. And this has been our plan all along. You might remember this guy. And so we are bringing this forward into kind of the same idiom, right? So an agent that comes alongside you and helps you do more with what you already have. Because the mission of Microsoft is to empower every person and organization on the planet to do more. And this is one of the ways we do that. Finally, in the first section here, I would like to talk about workloads on Azure are really naturally suited to AI. Because we're running in the cloud and your app is running in our environment, we're able to bring Azure artificial intelligence insights naturally suited to help you get more out of your Azure experience. That means AI-aware metrics. So you can think of it like an operating system that knows what your app is trying to do, so it can help you do it better. So the way we can do that is by having language experts and environment experts that know their domain and sort of connect those to the people doing the AI intelligent apps picture. So in my case, we probably have about overall 500 people globally, somewhere between 500 and 600, who are dedicated full-time to working with Java on Azure. And these are ranging from people who develop the Microsoft SDK, Azure SDK, which is a really great Java language binding for doing all the Azure services from your Java programming. And of course, there's language bindings for any other language that you'd like to use. There's even one for Rust. I see the Coding Club Lens has a Rust. So you can do Azure programming in Rust. But what we are trying to do is bring that language skill and connect with the teams that are doing the Azure services so that we can provide insights down to the line level of code. So we'll have a demo where App Service, which is one of our compute tiers, is able to do application insights and coding optimizations to discover what's wrong with your code and suggest how to fix it. So migration is an important part of that. Okay. I'd like to give a little demo, not demo, but I'd like to give some talks, some session content about Java and Spring on Azure Container Apps. Azure Container Apps is a relatively newer Azure Compute service, and we're focusing on three different value propositions: code to cloud, Java components, and monitoring and troubleshooting. I'll explain more what that is. First, I'll give a roadmap of where we are right now. So this feature is still in preview state, but we do have currently offered code to cloud, where you're able to consistently build and maintain and update portable or open container initiative, otherwise known as Docker images, with Java CNCF build packs. So we have build packs for all of these different technologies, Spring and Jakarta EE and Quarkus, for example. You're able to deploy your artifacts from source code or from a jar, for example. And at the operational level, you can manage these components without any operational hassle. Microsoft handles all of that for you. What we're doing next, coming out this month, is deeper monitoring and insights, kind of what I talked about before. Not initially plugged into AI, but we will be bringing those insights and connecting those things. It's kind of a bootstrapping process where, as I said, we're AIing all the things. And diagnostics is another factor there too. Dynatrace, of course, global experts in diagnostics and tracing, so they're a big partner in what we're doing here as well. I would like to pause and request kindly if you could take a screen grab of this QR code and try it out. This is one of those ways that my management is judging my performance, so if you would please scan this and try it out, I'd really appreciate that. So I'll pause a moment while people do it and just say there's also like a sweepstakes prize here that we're producing as well. And so this, what this will take you to is a survey, but there's also that aka.ms link will take you to some tutorial content so you can try out Java on Azure Container Apps. Thank you. The features about monitoring. So Spring is an important factor for enterprise line of business apps. We provide Java metrics and logs and integration with Azure Monitor, which I will be showing during my demo, and application insights. For diagnostics, the ability to get heap dumps, run those off into Java Flight Recorder or Mission Control is something that is very commonly done with Java developers. The other side of enterprise Java is Jakarta EE, and so this is where we're partnering with Oracle, Red Hat, and IBM to deliver solutions that run their enterprise app servers in various ways on Azure services. So virtual machines, containers, meaning Kubernetes, container apps, and OpenShift, and also various managed services. So we have a PaaS service called Azure App Service, and you can run JBoss EAP on that, for example. I'll run through these pretty quickly, but we have robust, up-to-date Azure Marketplace images for all of the ways you would possibly want to run WebLogic Server on Azure. I remember doing some consulting back in my JSF days, and there were certain very large Swiss banks that were using lots of WebLogic, so that's a popular feature for them. IBM WebSphere was another very popular thing. They have WebSphere Traditional and also WebSphere Liberty, which is a completely up-to-date cloud-native environment that brings all of the power of microprofile to your applications. And JBoss EAP is the third one that we offer, and that's either Wildfly or JBoss EAP commercial that you can run on Azure. We help it easier, we make it easier to run the commercial version because of our partnership with Red Hat. So any flavor of line of business app made easier on Azure. So regardless of the app stack you're bringing, whether it's Java or .NET or whatever, we have the compute, storage, and persistence and networking, high availability and disaster recovery, all of these key things that you're going to learn about more today. And with other resources at other global Azure events, you can learn how these work. So what we're trying to do is get all of these resources to work together, and they're frictionlessly enhanced with AI. You'll see that it's just, we're putting in the AI behind the scenes for you to make it easier. Now here's my demo. I've already deployed it yesterday, so if I would pause right now and go through and deploy the demo, it would take a lot of time, so we only have 45 minutes. So I'm going to just say, here's where it starts. If you want to scan this QR code, you can go to the app that's actually running. This is a cargo tracker sample app. And if you want to generate some load and interact with it and do some things and see what you can do, because when I put this into Azure Monitor, I did some interaction with the app when I was on the train from Vienna this morning on the Westbahn, but even more recent interactions would be great if you could try that. So it's bit.ly 2024-0420 GAA is the app, And there is this tutorial here that shows you how to deploy all of it on Azure. And it takes about 90 minutes to get it all stood up. And when you're done, you have a Kubernetes cluster fronted by an Azure application gateway. You have a PostgreSQL database. You have JMS queues set up for your messaging. And also, it's instrumented with application insights and Azure Monitor. So that's where, if you happen to have Copilot for Azure enabled in your subscription, you're able to do the things that are going to be shown in my video. It's actually not my video. It's Corporate Vice President Aaron Chappell's video. Okay, perfect. On time. So we're trying to just AI enable your line of business apps, and we're going to make it easy and frictionless to do that. In this section, I want to get down to the code level a bit, or explain how you can get down to the code level a bit, using two different technologies that are popular. The first one is called semantic kernel. This is a technology that Microsoft is developing, and you may have heard about our very high-profile partnership with OpenAI. Semantic kernel comes from that. So we are collaborating with OpenAI, and the semantic kernel idea is directly coming from our collaboration there. So if you want to get your hands into the partnership, you can use this technology. There are language bindings for lots of things, like I mentioned. So there is one for Java that I'm going to talk about next. But it works for all of the other kinds of languages that are supported too. So this is the Copilot stack. What semantic kernel does is the AI orchestration piece. And the AI orchestration piece will take plugins and copilots and also orchestrate them with the lower level foundation models. These are the LLMs like ChatGPT. You can bind it to other kinds of language models as well. So you have a choice of what language model you want to use. Here's a bit of a history for how we started. When we first introduced this semantic kernel, we had a simple back and forth chatbot feature. The next thing we added was RAG, Retrieval Augmented Generation for conversations. What that basically means is having a bunch of documents that you give into the AI so that your chat is informed by the content of the documents. I'll explain more about that later. A copilot is an agent, right, that works side by side with the user to complete a task. And the next thing here is fully autonomous agents that can respond to stimuli with minimal human interaction. So having a goal-oriented architecture like semantic kernel does will scale to this fully autonomous level of concept. So what is semantic kernel? It's a lightweight open source SDK that lets you orchestrate native code with LLMs. And when I say native, it's just whatever language you want to use. So it's not like, you know, native like OJI where it has to be C or C++. The word native has taken a broader meaning over the years, hasn't it? The semantic kernel for Java stack, its requirements are you need at least JDK 8 and above. It's available on Maven Central where Java developers get all their stuff. We also have it working on Android, and it integrates with all the popular AI models. It's open sourced on GitHub with the MIT license, and we have a ton of samples available that I'll show you how to get. And the samples are all based on Java 17+. So even though the core technology itself is requiring a minimum of 8, you can get more power by using a more recent version of Java, of course. Also, it works with Growl native images, and I'm sure everyone is familiar with Lin's programming hero and native Thomas Wertinger and his invention of the Growl VM, and so we make it work with that too. Conceptually, what you have is using connectors to connect your semantic kernel to models and memory. So models are the language models. Memory is the state that you build up during the course of your interaction with either a user, a human user, or some other system. Because remember, our goal is to allow it to scale to AI agents doing things on their own without human intervention or blocking for human intervention. On the other side, we have a number of plugins, and those are laid into the semantic kernel with triggers and actions. Now here's what some Java code looks like. I mentioned familiar idioms, so you can see using the builder pattern. So if you haven't seen it before, the builder pattern in Java and in any other language is that you have a number of object-oriented methods, and they all return the same method. I'm sorry, the same object that you can keep invoking instances on. And it's sort of an easy way to do a quick domain-specific language without having to invent a whole new language. So you're saying, excuse me, give me an OpenAI client builder. Let's connect it to a particular kind of endpoint, which would be your model. You, of course, have to give it some credentials, and you want it to operate asynchronously. That's where I talked about completable future, for example. And here we're creating a text completion service, and we're saying, here's pass in the OpenAI client that we just created, specifying the model ID, and then we're going to return a semantic kernel. So at the top of laser pointer, there it is. At the top, we're returning this kernel object that you further integrate with and do things. This is how you bootstrap it in your code. The way the planner works. So the planner is the heart of semantic kernel, and it takes various plugins to achieve a goal. So if you have a goal that says, can you write me a short poem about living in Dublin, Ireland, and then create a story based on that poem, it will invoke several different kinds of plugins to achieve that goal. And you don't have to specify what those plugins are. It already finds the best fit based on the language model that you're using. And it will come out with this reply here, right? This is an example taken from a demo that I will point you to, but I'm not going to run. Here is what the workflow looks like as we go from prompt to response. So here's another example. Please create a series of tasks to complete a marketing project. Once you're done, please summarize them and send them to my team. Now, in that prompt, you can see already a number of plugins are kind of implicitly being referenced. There have to be some plugins for doing marketing. There have to be some plugins for doing summarization. There have to be plugins for doing sending either emails or messages of some kind. So send those into the kernel. It will produce a number of steps, gather the skills. These are the different plugins. Gather the context needed to invoke those skills and execute the steps. And it goes back and forth depending on the model you're using and gives you a result. So planners started out as using the action planner. This would be able to choose one single best action to achieve the goal. The other one would be a sequential planner, which would generate a complete plan to do the goal, but it would just, once you started it, it would go to the end, or it would fail somewhere in the middle and not produce a result. The newer one is stepwise planner, where each step, if the previous step does not produce satisfying enough results, it will go back and reevaluate and sort of find a different plan to try to optimize and get the best result. I mentioned if you want to get more on the templates, or I'm sorry, get your hands dirty with this, some tutorials, you can go to this link here, aka.ms/awesomeazd. AZD is a tool called Azure Dev CLI, and it's a way to invoke infrastructure as code from the command line. And so with that, you can stand up all the environment you need to do all of these two different things. Java ChatGPT and Spring ChatGPT are the two ones that we have available now. That is semantic kernel. The other popular technology that people use to bring AI into line of business apps is LangChain for J. Well, it's LangChain, but there is a Java binding. So you can see the pattern, right? The world recognizes there's different programming languages that are better suited for different tasks. And whether you're using Java or .NET or Python or whatever, you find the best one that suits your needs. This session here I'm extracting, and the previous one also, from this really excellent conference. It was an online conference that my colleagues ran called JDConf. All of the sessions are on YouTube, and they have PDF downloads for all of the slides. And I really recommend you check it out. They're all short, like at most 30 minutes long, and they really cover a lot of broad techniques for all of what we have going with Java at Microsoft. One here that I'm going to be extracting from is one from Lise Reyes from OpenTide, and she gave a really nice presentation about LLM-powered applications with LangChain for J. That is the Java binding of the LangChain thing. You want to learn more about her outfit, that's the link there. Now these are the components of LangChain for J. You have chains and AI services. So chains are the way you can loop together all of the different AI services you might need to bind into your app. The basic side, they have language models and image models. So if you're working with images, you would be like DALL-E, for example, or DaVinci, or I'm not familiar with the different names of them, but they're all image models. And language models are the ones that I showed in the previous semantic kernel aspect. There's also a way to do RAG, Retrieval Augmented Generation, which she has a very nice explanation for, and I will get to that in a few slides from now. Here is like the chat language model. So first you define a system message. This is a thing that sets the context for the rest of the session. So for example, anything you want to tell the AI, I want you to keep this in the back of your mind as you compose responses. For example, explain something to me like you're talking to a 5-year-old person. That might be a system message that sort of influences what the AI is going to give you back. And then in the dialogue, you're having user message, AI messages, and all of those will be sent into the model and informing the answer that is aware of the preceding messages. So here's a great example or great explanation of RAG. And it was something that I didn't even know about until I started preparing for this talk, because my day job doesn't have anything to do with AI, really. But with RAG, it's basically chatting with your documents, as I said. So what you need to do is chunk up your documents into pieces to minimize the amount of context being used. Because if you're wanting to tell an AI, here's an entire book as the context, that's going to cost a lot more money than if you give it like 5 different paragraphs from the chapters that you're actually interested in learning about. So you chunk up the documents and to minimize the context use. Then you calculate a meaning vector on those documents you've chunked up, and there's tools for helping you do that. And you pass that into this embedding store. Then you also calculate a meaning vector for your incoming user question into the embedding store. And then there is some magic that happens that analyzes the documents and extracts the relevant segments for the question you're giving. And then you pass all of that to the language model. So you can kind of think of it as pre-processing before you get to asking the LLM. Okay, we're a little fast on time, but that's okay. So what you can do in using AI in your line of business apps is to either look into semantic kernel or LangChain, and I recommend you check those out. Next up, now that we've talked about the code in the line of business apps, let's talk about how to take it up a level, because your line of business app is running as part of a larger context. It's running on Kubernetes, it's running on virtual machines or OpenShift or Azure Container Apps. How do we instrument that with AI? So we have 3 basic things here. Microsoft Copilot for Azure, Azure Application Insights, code optimizations, and the Diagnose and Solve blade in the Azure portal. Now let's check in a bit on the demo here, and I will bring up Application Insights and see what we have going. So let's pause the timer, and I think I can go escape. Will that work? I hope it keeps my timer. All right, let's go off and turn on mirroring. All right, great. And let's go back to the Azure portal. So I had deployed my app. You've got the cargo tracker running here. Let's reload this. And what this app does, it's just a sample app that uses domain-driven design to show how you can use a database, a relational database, and messaging queues and achieve a typical line of business app interaction. So let me go to some of the other windows I have here. Not this one. There we go. I'll reload this. So this is the tracking info with the routing details for this cargo that I started routing this morning. And it's shipping from Shanghai to Hamburg, and it's going on a really ridiculous route, but you know, that's just a sample app. So in the tracking interface, you can take this routing code and go here and paste a new one in. And the next expected, oops, sorry, there's a state problem there. Let me reload it. Oops, I'll just close this and open it up from the home page like I'm supposed to do. Public tracking interface. Now I want to do it in a new window. Open in new window. There we go. And face this. All right, next expected activity is to unload cargo off of this route in Dallas. So there is a little mobile event logger here, and I'll reload that, and I'll pick my tracking ID, say next, and I'm saying in Dallas, I want to, what did it say? Unload. So I want to unload my cargo off of, I think it was 0400S, right? Here we go. Next. And completion date is, we'll leave that right there, and submit it. Okay, event submitted. Now if I go back to the tracker and reload this, it should give a next step. Yes, so now it went from unload to load onto the next step. So the reason I'm doing this is just to generate load. I hope some people also generated load also. Let's go to Application Insights. Here it is. And this is my Azure portal. Let's select the resource group where I have this deployed. And these are all the things that you get deployed from the executing the tutorial. Now, one of the things I mentioned, the tutorial invokes from the command line the same bicep template that you have in the Azure Marketplace to deploy OpenLiberty or WebSphere Liberty on Azure Kubernetes Service. So it's using from the command line the same thing you can do from the Azure portal. I do want to show that just as a preview if someone is curious to talk to me during the coffee break. If you go to the Azure portal here in your subscription, and you could go to any of the technologies that I mentioned earlier, and let's just type in WebLogic, for example. And when it loads up, you'll see we have these Azure Marketplace entries. Deploy WebLogic server on AKS, for example. And you can just go ahead and say create, and then you're immediately able to spin up what would be a quite complex migration technology on AKS. And you have commands for setting up the cluster, bringing in an existing cluster if you want, integrating with Azure Container Registry, having several different load balancer choices, automatically configuring a data source, including passwordless databases. So if you're running your database on Azure, you can use passwordless, which uses a managed identity instead of the less secure version of username and password. That's already integrated. Okay, but let's go into Application Insights. And there's a few features that are kind of fun to look at. The application map is one. And so this one is showing here just a very basic app, because this is just a CRUD application essentially. And it's showing the number of calls that are going from the app server to the database. And you can drill down on the database and see, investigating the performance of your database, for example. You can see that over time. And you can see what's happening with the select statements. So that's really, really deep. And all of this, if you have Copilot for Azure in your client, in your subscription, you'll be able to ask it conversational questions about this. This particular subscription doesn't have that. So I have a video I'll play that shows what that looks like. But I wanted to say that the depth of the application is separated from the AI that you can use to enhance it. One other application insight I want to mention code level resources. So if we go to failures, is this application? No, that's Kubernetes. I clicked on the wrong thing. We want sort by type, and application insights is right here. And one of the views is failures. And I had, yes, made a few bogus requests. So I'm going to make another bogus request just so we have it fresh. So I'm going to open up data.json. You don't really need to read what I'm doing. I'm just going to make a bogus date here, using the wrong date format. So April 20th, and we'll say, instead of 6:47 a.m., I'll just say half past noon. So that's not a valid date time, and it's going to cause an exception. So let's run the REST call that calls it. And here it is. Oh yeah, 400 bad request. Okay, that wasn't the error I was hoping to get. I wanted to get a 500. Echo, okay. Yes, that's correct. All right, let's try one more time and see if we get that 500 error. Okay, well, maybe we'll look at a previous one. It should still be there from when I did it on the train. Yeah, there's the 500. So you can see if we drill into samples, you can see the exact code level of where this exception is happening. And it's a date time format exception invoking this method here. Could not be parsed at index 0. Yes, handling request. Now, the fact that we're able to give code level insights here shows that when we hand this off to Copilot, if Copilot is aware of where your code is, it can get into the level of saying, okay, fix this line, or if you want to add this feature to do it. So let's keep going back into the slides. Play from current slide. Oh, and it lost my time. That's a pity. Okay. Well, let's talk to Erin Chappell, CVP of Azure, and see what she has to say about this.
Now, we've talked about a number of innovations spanning the entirety of Azure today. Taking a broader view of the entirety of your IT environment, it comprises many services with thousands of resources, all of different types. And you need to manage all of this. Enter Microsoft Copilot for Azure. Copilot for Azure will help you gain access to all the knowledge held within your growing IT estate. By combining advances in LLMs with the rich data, policy, governance, and access control in the Azure Resource Manager and the Azure Resource Graph, Copilot for Azure lets you easily interact with your entire cloud environment. And it's your agent that helps you act on all of that knowledge. Let me give you a preview. Copilot for Azure can be accessed anywhere at any time from the Azure portal. And with it, you can talk to Azure, naturally, asking questions like, how many resources do I have? Copilot understands and quickly answers your question and invites you to ask more. Related questions are suggested, and I can continue to explore, asking, what are the most common resources? How many VMs do I have? And what regions have the most? Copilot also gives me the Azure Resource Graph query I can run to further explore the data and interact between the main query window and the conversation with Copilot, going back to ask what was created in the last 5 hours. But operations are more than queries. I can perform management operations as well, such as tag these VMs with demo, or show me the memory usage trend to drill into the specific metrics. I can even run management operations like reboot this machine. Beyond the resource model, you can use Copilot's knowledge, enriched with Azure documentation and best practices, your billing data, and service logs and metrics, to instantly generate deep insights, easily discover new cloud functionality, and more quickly get complex tasks done. Cloud environments have hundreds of rapidly evolving offerings, and understanding their capabilities and how they compose can be a full-time job. When something isn't working right, even the most accomplished expert has a broad surface area to start troubleshooting. Copilot for Azure provides AI-guided troubleshooting that helps you more rapidly identify issues and solutions so you can solve problems faster. For example, Copilot is deeply aware of individual services like the Azure Kubernetes service, providing a huge boost to productivity when troubleshooting complex issues by surfacing the right tools, suggestions, and mitigations. I got an alert that a node has high CPU utilization and can ask Copilot, what should I do? Based on the suggestions offered, I select, how can I add more nodes to my cluster? Copilot then helps me navigate the portal tooling to correct settings to scale, rapidly identifying the solutions so I can finish this troubleshooting quickly. Navigating the initial learning curve to adopt new technologies presents an opportunity for teams to acquire valuable skills to revitalize an organization. Whether you're starting with a simple web app or choosing to modernize your application to be cloud native on Azure Kubernetes service, Copilot for Azure helps you learn, understand, recommend, design, and deploy the right services and infrastructure for your workload. Copilot always has the most up-to-date data and information so you can design, build, and deploy your organization's solutions in a more scalable, flexible, and cost-effective way. I can ask questions like, what service should I use to run a high-scale web application? How does that compare with other services? What data store would I add for a read-heavy NoSQL workload? And then Copilot makes it easy to deploy using CLI or ARM and Bicep templates. Application teams often need to optimize for performance and cost. It's critical for teams to get insights into spending and get recommendations on how to optimize, forecast, or perform what-if analysis. Copilot can help you understand your invoice and spending, changes, and outliers. For example, Copilot can summarize my costs for the last 6 months, understand what subscriptions caused the increase in December, get recommendations for how can we optimize our costs, and get answers based upon the up-to-date cost management, usage, and billing data. I can also get recommendations for optimizations at the individual service level. With Copilot, you can more quickly optimize your cloud environment on the dimensions most important to you. I'm excited to announce the preview of Microsoft Copilot for Azure, your Copilot for cloud operations and management. Now, more than...
All right. So let's summarize it. For looking at the other sessions, all of them are great. Start this one, the next one up, I recommend. Do finally please check out Java Spring on Azure Container Apps, and also check out Jakarta EE on Azure. This QR code here will take you to a system where you can win a free, or get, and I don't have to win, you just have to fill out the survey and get a free ebook about Java on Azure. So thank you very much for your time, and have a great Global Azure Day.
Wonderful. Thank you very much. Thank you, Ed, for doing a quick introduction and a very good overview. So now we are curious to learn more about semantic kernel, language models, various DevOps options, and thank you for pointing out the sessions. Regarding your session list, I have one announcement. Unfortunately, Tony Pohl is sick. He will not be with us today. We wish him the very best, and we hope that he will be well pretty soon. All the other sessions will happen as announced. Speaking of sessions, Ed, will you be around for another few hours here at the event?
I'll be here the full day.
Perfect. Then I would suggest that we do some questions and so on directly, maybe in the upcoming breaks or during lunch, if that is okay for you.
Of course.
Perfect. Now, you have 5 minutes to get the sessions going. After this keynote, we will dive into certain areas. So pick the session that you want. Maybe quickly run up, run down, get a drink, get a coffee. Feel free to take the coffee with you into the session room. Bring the plates back afterwards and choose the session. And we wish you a very nice day here at Global Azure. If you have any questions, come to us. We will start with the sessions in 5 minutes sharp. A larger coffee break will be after the next session.